this video starts off our next topic, which is going to be on momentum, impulse momentum theorem, stopping distances. Later on, you'll also be looking at different types of collisions, perfectly inelastic, inelastic, elastic, and then conservation of momentum. Once again, looking at collisions. So on this video in particular, we're going to talk about momentum, impulse and force, and stopping distances. First thing we'd like to look at is momentum and impulse. Definition for momentum is quantity defined as the product of the mass and velocity of an object. Quantity defined as the product of the mass and velocity of an object. Okay, so with that in mind, guys, check out that definition one more time. It says quantity. That means some numerical value, correct? Defined as the product of. Well, what math operation are you doing if you were getting the product of something? Tell me. Okay, great. It is multiplication. Okay, so you're going to multiply the mass and the velocity of an object. So the equation with using the correct variables, and this would be considered the E in your guess method, as in the original equation if you were asked to calculate the momentum or one of the two variables that we're about to write on the board that are in the original equation, the E that is found beside the S and substitute in your guess method for any math problems that you would accomplish in this course. So the original equation is lowercase p equals m times v, whereas p stands for momentum, m stands for mass, and v stands for velocity. Okay, so looking at units, your velocity is in meters per second, and your mass is in, what is mass always in physics? Like, what's the standard units that you want to go to? Recall this. So you want to be in kilograms, right? Okay, so if you have kilograms and meters per second, there's no derived, like a Newton is kilograms times meters per second squared. There's no derived units off of this. It's just the standard units. So if you're multiplying mass times velocity, guys, instead of multiplying the variables, take a quick second and multiply the units. So if you multiply the units, your equation would then become momentum equals what units here? What would you put as your final answer? That final answer would become kilograms times meters per second. Agreed? That's what the unit should be for your final boxed answer if you're talking about, hey, I missed order, I just saw it for momentum, so I'm going to box 62.0 kilograms times meters per second. Make sense? Okay, so once again, the original equation is going to be this guy right here. So my suggestion would be start an equation sheet, guys. So this is the original equation that you're going to use in the guess method when it comes to solving for momentum problems, or if you solve for mass and or velocity inside a momentum equation, just depending on which one is your U when you utilize that guess method. Okay, so knowing that you're using mass and velocity, guys, one of those two for sure leads you to let you know that momentum is either a vector or a scalar quantity. But time out, let's recap. What is the difference between a vector and a scalar quantity? Talk at me here. Although we're not seeing each other face to face, talk out loud. What is the difference between a vector quantity versus a scalar quantity? Sweet, thanks for answering. So scalar quantity shows magnitude only, and vector quantity is different because not only does it show magnitude, it also shows, good guys, direction. It also shows direction. Okay, so here's the million-dollar question. What would momentum be considered as? Momentum shows magnitude and direction because of which variable? Is it the mass or the velocity? It's the velocity, because velocity is also a vector quantity. So if your velocity is going to indicate either a positive or negative quantity, listen to that, please. It is telling you the direction by saying negative and positive. It's not saying a negative 62.0, nor is it saying a positive 62.0. It just means 62.0 whatever, meters per second in this case, because that's the blue units on here, in the opposite direction of travel, right? So like forces would be negative, correct? Because, let me be more specific, frictional forces such as kinetic friction and the maximum static friction of an object would be negative, quote unquote, quantities because they are traveling opposite, i.e. negative, the direction of motion. So let's just circle vector here for momentum. Momentum would be considered a vector quantity. Look at this little blurb here, okay? Read this little blurb. It says the direction of momentum vector. Yeah, it's like right there. Just read. Read the question there. The answers are embedded right inside of them. Think while you're reading. Don't just be robotic on this and just run through the motions. Stop and assess this. Furthermore, when you're watching these videos, please mark beside them little stars. Miss Arter needs to go over this with me. I'm confused on this comment. Please do not be afraid to come approach me on this stuff, guys. Moving right along, example of momentum. So you're on your bike, all right, and it's a nice flat surface. You gotta pedal, and then, oh, sweet, there's a hill coming up. So there's a hill coming up, and you want to act like the 5-year-old, right? We all do it. I do it. I ride my bike like all the time. So you start to go down the hill, and you put your feet out to the side. How in the world are you still moving, right? Because that's my question here. What happens when you're riding your bike down a hill without pedaling? You're still moving. But be more specific. Are you moving at a constant velocity, a slowing down velocity, or a speeding up velocity? I.e., are you moving at a constant velocity, or are you accelerating in the positive, speeding up, or in the negative, slowing down direction? Okay? So when you go down this hill, you are speeding up, correct? So you are accelerating. So you're increasing your velocity. Well, what is staying constant, guys? This is a good one, because I'm sure some of you are saying my mass is staying constant. Well, you're not taking the whole entire system into consideration. Just like variables, you got to stop and think. Who's my dependent? Who's my independent? Who are my controlled variables? Are you changing the bicycle throughout this? No, you're not changing the bicycle throughout this. So therefore, it is the bike plus the mass of the person. That is what your M total should be. So in your givens, you would have an M1, you would have an M2, and then maybe in parentheses an M total. But technically, that's showing work. So you should have an equation that says M1 plus M2 equals M total. So you have the mass of the person plus the mass of the bike equals the total mass of the system, bike and man, for this problem. And then you would be able to move on to P equals M times V. So long story short, what happens here, you have an increase in velocity, i.e. accelerating as mass, bike plus man, remains constant. So therefore, think about the equation, kiddos. What's the equation once again? Slide back a few slides here. The original equation is P equals M times V. Your constant is your M. Your V is what's increasing. So take a second here. How does the momentum responding variables, to this increase in velocity? Well, then you got to look at the equation. Once again, the equation was P equals M times V. Well, if your M is your constant, P equals V. Therefore, you have a direct relationship. So, therefore, if your velocity is increasing, then your momentum is going to be doing what? Excuse me. It's also going to be increasing because they are directly related. Hey, graph this stuff for me. Your mass is constant, P equals V. So momentum's on the y-axis, V is on the x-axis. What type of graphing relationship are you going to see? Check out the equation. There's no squares, nor are there any square roots. So since that is present, then that would be what type of graphing relationship? That would be simple direct. You with me? Okay, fabulous. Moving right along. Okay, another example. You're rolling a bowling ball and a kickball down the same alley at the same velocity. So the thing that you're changing is mass, right? Velocity is staying constant. Well, in this case, once again, you're using P equals mv, whereas the velocity is changing. So P and M are directly related to each other, which would mean as the mass goes up, then the momentum would also go up. And once again, it should be a direct relationship. Excuse me, it should be a simple direct relationship that you would see if I would ask you to graph momentum on the y-axis, the dependent variable, and the m being the independent variable. You walked into the lab knowing that the bowling ball was heavier than the kickball, so you should be able to guesstimate, hypothesis, what the slope should be for each of these. Which one's going to have a greater slope, which will have a lesser slope. That kind of a thing. There's so much you can read off of this just by knowing the relationship between the variables. Moving right along. Here's our first sample problem. Let's utilize the guess method correctly. Please write down the givens that you see. Please write down your unknown. Please write down the original equation followed immediately by the substituting in your numbers, your variables, quantities, and then your calculated answer followed by your final answer box with correct units and sig figs. So it says a 2250 kilogram pickup truck has a velocity of 25 meters per second to the east. What is the momentum of this truck? So speak with me here, guys. What do you know going into the problem? Go in order here. So the first thing that you know is the mass of the truck, 2250 kilograms. Okay. Next thing you know, good, your velocity, which is 25 meters per second. Well, if it says 25 meters per second to the east, is that a positive quantity or a negative quantity? It's positive because it's heading towards the east. Your unknown is your momentum. Please remember to include your your units with your variables. So the correct units that would be assessed here are kilograms times meters per second. The original equation would be momentum equals mass times velocity, whereas momentum is what you're trying to solve for, so you do not need to rearrange anything. So 2250 times 25. All you have to do is take a quarter of 2250. You can totally do that in your head. A quarter of 2250. And that's the number you want to multiply by. With me? Okay, so that would mean that your calculated answer should come out to be 56,250. Please have your calculators out. Please be calculating these as we're going through the problems. Okay, so assess this number right here, your calculated number. How many sig figs are in 2250? There's only 3 sig figs. How come there's not 4? I see 4 digits there. Well, yeah, it's that story on that 0. It is crazy important to put that 0 in there, because if you just write 22.5, that's 250. That is not 2,250. But that 0 is still significant, because if there is or is not a decimal there, you would be able to imply how many digits literally are significant in the final value of this problem. The next one, 25. That would be 2 sig figs. Guys, what do we do to determine the number of sig figs for the final answer? We look at our givens and we assess the least number of sig figs. So the least number of sig figs would be 2 sig figs. Sweet, let's go over here. What does the 2 do to the 6, guys? Does the 2 round it up or keep it the same? Keeps it the same. So our final answer is 56,000, or 5.6 times 10 to the 4th kilogram meters per second. Okay, Miss Arter, grade this one. Put a nice little box around it. Yay! Okay, success. So the next thing that we're going to talk about is the impulse momentum theorem, but I'm going to stop right there so we don't have to put that one on 2 separate videos. So this video pretty much is just the momentum. Please finish your momentum questions after this. If you did not get a worksheet in class, the momentum worksheet is posted on my teacher page. Please do not waste your own paper. Just get a piece of notebook paper out and copy down the questions, unless using your own paper is not a problem at home. All right, good job, guys. Thanks.